So thank you, everybody. As you can see, it's going to be in English. We're from SoftBank Robotics. We're based in Paris. And we're here to introduce you Pepper, so our latest robot. And this is Jonas and myself. So as you can see, we are manufacturing robots that are looking like people. There's a lot of robots already around, industrial robots, vacuum cleaners, mown mowers. But we, or SoftBank Robotics, is developing these robots that are emotional, that are interactive. So not robots that are be handling things or cooking or bringing you coffee, but more robots that are going to be interacting with people. So of course, we can discuss with Pepper. Hello. Hello.
Hello.
How are you? How are you?
I'm super good, thanks. And you, how goes it?
I'm doing good.
Great.
Can you introduce yourself? Can you introduce yourself?
My name is Pepper. I'm a humanoid robot and I'm 1.20 meters tall. I was born at Aldebaran, in Paris. I'm very happy to meet Andrea and Jonas from Aldebaran here at the Big Tech Day. You can keep on asking me questions if you want.
Do you have brothers and sisters? Do you have brothers and sisters? Okay, she doesn't want to see me now. No worries, we're going to get there. So as you can see in our history, we started in 2005 in Paris. So it was actually a French company before. Yeah, the mic is here. Hello? I can just keep it like that if you want. Good? Okay, no problem. We started with Now, which is also a humanoid robot. It's a 58 centimeters tall robot. You can see it here. It's playing soccer, but it's not only playing soccer. It's a research and artificial intelligence platform that is widely used. Here in Germany, we have around 700 of these robots, universities, schools. And in 2012, so SoftBank, which is a telecom provider in Japan, acquired 70% of the company, and with their inspiration of creating a larger humanoid robot, which is Pepper, to be not only in stores, but also at home. So this robot is already in homes in Japan. We have around 18,000 of them, but we'll get there. So right now, since actually last month, we became SoftBank Robotics, so we left Aldebaran, which was beforehand our name. And right now, we're launching Pepper here in Europe. So this is quite new. In terms of who we are, our headquarters is in Paris. We also have some offices in San Francisco, Tokyo, and Shanghai. We are 500 employees. Half of them are in research and development, so in software, mechatronics, electronics. So all of this research is based in Paris. But of course, we have some other peoples elsewhere in the world, so you can see the map. We have 18,000 of Pepper in use in Japan. So as I mentioned, 10,000 of them in B2B, retail, healthcare, and hospitality, and 8,000 of them already at home. So entertaining and having fun with the kids, reminding them about their schoolwork and so on. Yeah. Of course, we're working with some partners, hardware partners. For example, in the voice recognition, text-to-speech, we're working with Nuance, that all of you know probably, and with also other type of partners that are manufacturing the robots as Foxconn. Of course, in this area, this is also only the technology side, but in terms of software, we're also working around with a group of partners that are developing the solutions for our robots. So this is what we're going to be telling you today. In regards to our robots, I mentioned that we're doing some interactive and emotional robots. These are the base of all of them. You can see now the 58 centimeters tall here. So mostly used in education, but also some companies already use it. Romeo, which is a research platform, we're collaborating with 5 universities and research labs in France. And our goal is really to have a robot that will be helping out elderly people. And Pepper, which you know is already here. Of course, before I come down to them, and you're going to be learning today about this user interface, which is very important to know, that all of our 3 robots are running with our own operating system that is called Naoki. And they also have, we can program them with the same programming tools, with the same SDK, so it's really basically the same interface for all of them. In regards to the software, so I mentioned that we're collaborating with a large group of companies. So we have 30 of them. One of them is here at No DNA in Munich. So for any type of development, they're also the ones that can help us out. So we have these companies that are developing end solutions or specific applications for retail, for instance, in supermarkets or in shopping malls, in hospitality, so in restaurants, bars, hotels, and also in hospitals, as we've seen some use cases for elderly care, but also for hospitals with children. So what we are doing is creating this large group of partners that are not only developing the applications, but there are also user experience companies, there are artist directors, we're testers, there's business developers, there's tech providers. For instance, we're working with Watson, IBM Watson, we're working with Microsoft Azure, we're working with MasterCard that are doing the contactless payment terminals with a Pepper. There's so many other possibilities that we're having, so we're really open into exploring how you as tech guys or as software guys can develop new generation of applications for a robot. So what we're gonna present today is, okay, what type of software development tools we have, and then how we can use them. So I pass on the word to Jonas.
Here. There we go. Do I need to hold the microphone as well? All right. So the robot you see here is a humanoid. That means it has a human interface, well, human-like interface, a face, 2 arms. This one has only 1 leg, but this is more for simplicity of the platform and being able to hold a working day in any business without breaking or falling or having any problem. The robot is basically running on a computer, running Linux. There is a processor in the head, an Intel processor, and has different interfaces like microphones here. And I actually should. Yeah. There we go. Microphones on the head. You have seen Andrea battling to have the robot looking at her. There are cameras here on the forehead, 2 3D cameras in the eyes, another camera in the mouth that actually sees in front of the robot, in front of the feet. The microphones are directional. That means they are not listening to the background, but only focusing on the people in front. That means we focus the robot on one-to-one interaction. So that's what we are going to talk about today. We see that robot in shops, in customer-facing environments. That means you come to the robot can greet you, present you all the products of a shop, the different pieces of a museum, how to check in a hotel, and so on. It has a screen, so you can display information. It's a touch screen as well, so you can also enter information that we try to use mostly as fallback if the robot doesn't understand you. And then it has some microphones to be able to talk with you. If you come around later, you will see all around the robot a lot of sensors everywhere that are more here for security reasons, to make sure that the robot doesn't hit someone or doesn't go wild at any time. And this is, so I'm sorry, it will be a bit more complex holding the microphone at the same time, but I'll try. Let me just deactivate that demo thing. Oh, deactivate. This is the software we use for programming the robot. It's called Choreograph. Of course, all the common languages like Python, C++, or Java can be used for programming the robot. We provide all the libraries for programming the robot in all those languages, but we also provide that software, which is a very, very good tool, an easy tool for prototyping things, trying out new demos very quickly. It works in a very easy way. You have here a list of what the robot can do. You have here your programming area. You see the robot, you see what the robot sees.
Hi. Hello.
And if you want the robot to do something, then you just have to look for the right function. So if we want the robot to speak, for example, we just grab somewhere a function called say that we drag and drop here. It creates what we call a box. And a box is one of the basic functions of the robot. That box has input to start or stop the speech, output to make sure we can do something else after the speech. Then I have my first program, just have to click play, and the program is sent to the robot and run. So it should say hello. It should say hello. Pepper, say hello now.
Hello.
There we go. So of course here it just says hello, that's the default content of that box. If we want more, then we have to dig into that box. Inside you have 2 more boxes. You see here the hierarchy from the root page. We're now in the say box. And there I just have to change the text if I want the robot to say something else. Hello, my name is Pepper.
Hi.
The good thing is, well, there are still some automatic things running, so that's why you hear the robot saying things randomly.
Hi.
Oh, come on, stop that.
Hello.
You have here the list of all the languages the robot can speak. You can speak, well, our platform can speak 21 languages. The Pepper itself, as it's brand new, doesn't have the 21 yet, but it's to come. So it can speak English, it can speak German, French, many other languages. Only one at a time, but you can speak and understand that language. That means you can switch between languages very easily and make it speak German if you want. I'm sorry,
Hi.
I'm just going to make it speak English right now. I'm just going to stop the autonomous thing. Hey, you're supposed to rest now. Hello? Are you sleeping? Yeah. All right. Then it will stop talking. So we changed the text here. We just have to click play again as soon as it's waking up. There we go. I'll just click play again.
Hello, my name is Pepper.
And the robot says the new text. That's very easy. This is the voice synthesis from Nuance. You just write down the text with punctuation, and it reads it. If we want to go further than that, then we have to continue digging, double-click, and get to the code behind. This is where it becomes interesting. This is where we notice how speaking is working. The only line that is actually interesting is that one with a function called say, which is embedded in the robot. And that line can be used in C++, in Java, in Python, in JavaScript, in any of the languages we support. That will be the same line, and it's the same for every function. If you want the robot to move 1 meter forward, you just have one function called move that you can use directly. So, today what I would like to do is create a small application that will make the robot present products. I said at the beginning, this is a robot we intend to put in shops to welcome customers and present things. I have created here, not that here, where is it? I closed the folder, let me open it up. There we go. I downloaded here, here, 2 images. This is a phone I want the robot to sell. I have the front and the back of the robot. I want the robot to sell that phone. Okay. I tried to find a phone without a brand on it. It's not so easy. So, for that we don't want the robot to only be speaking. We want the robot to be discussing. So for this we want to create a dialogue topic and not only a say, so a speech. We want the robot to be able to understand what I say and to answer accordingly. So let's give that a name. Demo dialog. You can see here all the languages as well. I'll just be lazy and do it in English only. And this appears as another box. The content of that dialog right now is empty. You see the sharps here for commenting. But you have some help Just have to uncomment that one. And this means when the box starts, the robot should do this. The way it works, can you all read or should I put it bigger? No, it's fine, right. The way it works is you have these rules called U something. Between the brackets is what you say to the robot, so the trigger to trigger the answer that is after the brackets. So if you have a simple rule like that, hello, and then the robot answers, hello, Jonas, how are you? There must be many mistakes, yeah. It's all phonetics, so if I put hello, the robot will just say hello. It will not correct my orthograph. Oops. Just going to remove that. Good morning. Huh? No, it's too far. So here what will happen is when the box starts, the robot will say good morning, and then it will just start listening. This is what we call a dialogue. The dialogue engine is just a robot listening for triggers. There is only one trigger. I can have as many as we want. Right now we have only one. If we say hello, the robot should answer, hello Jonas, how are you?
Good morning.
Can you say hello? Hello. Yes, speak loud.
Hello.
Hello, Jonas. How are you?
And you see the robot moving at least. Here it do a little waving movement. Those are automatic as well. So it looks at the different words I'm using in the text to do the right movements. Of course, we can force to do some bigger movements and nice things and so on that we'll see later. But right now we want to sell a product. I actually cheated a little and prepared some sentences. No. Here. Copy and paste. There we go. So the robot will ask me, how are you? And then depending on what I answer, good or bad, the robot then, I'm happy to hear that, or I hope I have the perfect product for you. And then you see special comments here, go to, reactivate. This is the same as go to you have in any language. It's just go to another sentence that the robot would say. I have also prepared that sentence. Then the robot has here a new proposal. So a proposal is basically a question the robot will ask or something the robot will say. This proposal is called Ask Question. And we'll say, so tell me, Jonas, what kind of phone would you like? Let's play this.
Good morning.
So we say hello. 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 Hey. Hello.
Hello, Jonas. How are you?
Good. I'm good.
I'm happy to hear that. So tell me, Jonas, what kind of phone would you like?
So, now the robot is getting in business. He offers me phone. Good, but then, after that, let me try to make it bigger. There we go. After this proposal, I cannot answer anything. There is no other content right now. So, let's create some. Press the mouse. I want an Android phone, I don't know. Or I want a big phone. What could the robot answer here? I haven't prepared that one. I have one. Okay, I don't know. You should know. Why do you? Why don't you look around for your phone. And a big phone. Up. Come on. They're all getting bigger and bigger anyway. We should have everything you need. So different answers. You see a difference here. Those are U rules. Those are U1 rules. This is kind of a hierarchy. A U rule is available all the time. That means if we say hello or if we say good or bad, it will still be here right now. But all those U1 rules, they're only available when we are in the right proposal. So as long as the robot has not said that, then those answers are not, those triggers are not available. So right now we could still say, I'm bad. I'm bad.
Oh, I hope I have the perfect product for you. So tell me, Jonas, what kind of phone would you like?
So always selling things. So let's play it with the new dialogue.
Good morning.
I forget my script. Hello. Hello. Hello.
Hello, Jonas. How are you?
I'm good. I am good.
I'm happy to hear that. So tell me, Jonas, what kind of phone would you like?
Big. A big one.
Ah, they are all getting bigger and bigger anyway. We should have everything you need.
So you see the robot answering, you see the robot moving, but it's, well, the sentence can be very fun, but it's still kind of boring. The robot is speaking, answering, and that's it. No real content behind. This is where we need to think user interface, we need to think user experience. We have some small adjustment that we can make on the speech, like slowing it down, make it the pitch change. But mostly we have something much more interesting that are some sounds that you can play and some animations that you can make the robot do. Let me find one. So we'll add this special code, this accent run with the name of one animation. So the robot does something, actually. When I say hello, it just not only say, hello, Jonas, how are you? It also plays a little animation at the beginning. Let's see how this goes.
Good morning.
Hello.
Hello, Jonas. How are you?
And it didn't play my animation. Very nice. I love those robots. Let me check the name. Maybe I misspelled it. So we have a library that you see here of about 640, I think, animations that are embedded in the robot. The robot, when it speaks, tries to use among 25 of them that are all those body talk. Let me put this away. Here you have some body talk that are used. If we play them, you see the robot moving in different ways. Those are the simple animations that are used in the dialogue. Should we put the robot in the middle so we can see it? Tu peux le pousser? Nice. Merci. But we have much more than that. So if we want the robot to be confused, there is a special animation. The robot is confused. I don't know what's happening here. If we want the robot to be hysterical, yeah, kind of hysterical, or to mock you. All those animations are embedded. So that means when your customer is coming, you can do something that is actually catching and not only just speaking to it. It has to be catchy when you have the robot speaking to someone. So which one did I want to use? Emotions, positive, interested. I think I'm just missing that line here.
Good morning.
So I'm going to cheat a little. I will type in the answer here. So it plays this little animation.
Hello, Jonas. How are you?
And then we could continue going on and on. This is a first step. You have an animation. You have 600 animation existing. Okay, but let's create ours. So I'm just going to stop this and create, oh, you cannot see here. And create a new box that this time will be a movement. The way we teach movements to that robot is simply by showing it what we want to do. So I activate a mode that we call the animation mode. And in this specific setting, I can simply touch the different sensors of the robot to move the different limbs of the robot. So we'll say that the animation starts from a normal position. If we press the head, you see here, this gray square here represents a position. This is the first position of my animation. And then I want the robot to wave. So I have to record all the keyframes of that movement. So waving is quite simple. Go from left to right. So we'll go one here. Is it saved? Yes. One here. Here again. And then go back to a normal position. Save again. So I just shown the robot. All the motors are controlled, but are also deactivable. That means you as a human or as a user can move the robots, the motors, sorry, and the robot sees the position, sees what you're doing, and actually can actually record it. What you see here is the actual position of the robot right now. What you see, those bubbles here, they are the faces the robot see. If you move the robot, then you see the view following here. There are sensors everywhere in the robot, including in the motors. You can read very easily the speed, the position, the temperature of the motors as well, because if the robot holds like that his arm, I promise after 30 minutes he will be dead. But anyway, if we want to go back to that, I will just deactivate the learning mode. If we want to go back to a different position, just click on it and see what happens. We can easily check the animation. And of course, we can also play it at the normal speed. So that's a little robotic, but still waving. Of course, the animation is a real job. We have some very strange positions in our company, like animators, like actors and things like that to program robots. I'm only a programmer, so don't worry too much about this. But the thing is, we now have a new movement that we can use very easily in our dialogue. So I'm just going to integrate that, let's call it waving. Up. Cut. And paste here. There we go. And from that dialog, instead of running this embedded animation here, I'm going to run ours. I just need that. That I called waving.
Good morning.
Hello.
Hello, Jonas. How are you?
So you can see the difference first with my kind of crappy animation with those very nice movements that are already embedded in the robot. But what's behind that? That means if you have specific needs for the robot to do some other things that we haven't foreseen or we haven't predicted, we haven't embedded, in all those applications you have seen here, you can easily, you have seen in like 1 minute, we have created a very small waving. You can create as many movements as you want and integrate them in any application as you want. So that's very powerful. More than that, here it can be funny, but we need to be even funnier. I will add a little sound. Another one here. All right. Those are also embedded sounds.
Good morning.
Normally. All right, let's stop cheating. Hello. Very nice animation.
Hello, Jonas. How are you?
I'm good.
Oh, I'm happy to hear that. So tell me, Jonas, what kind of phone would you like?
An Android.
Cool. Okay, sure. I have one.
So you've seen the effect that can, just with two small sounds we can do on a robot. That's all about the user interface, the user experience. We have a library embedded in the robot as well of about, well, exactly actually, 1,779 different sounds that you can play on the robot. I'm not going to play them all because they're very numerous, but the idea is we have built those sounds in order to have the robot in a smooth way when it talks. So the sound can be kind of integrated with the voice without being too surprising for the user. So the idea behind that is if you need something to be very catchy for the user, for the people in front to stay on the robot, then you also have everything you need without recreating everything yourself. Then, so we have movements, we have sounds, we have the robot understanding us. There is still a big sensor that we haven't used, a big display here that is able to show very easily information. For this, I have built, let me open it as well. CSS, yeah. I have built a very small web page. Yeah, if my computer wants to show it. That is basically displaying Pepper. There we go. And we can very easily, as the robot embeds a web server, embed that web page in the application. So the screen here can display.
I'm happy to hear that. So tell me, Jonas, what kind of phone would you like?
So the screen can display that web page. The good thing here is we provide a library for JavaScript so that in your web page you can also interact with the robot. So here, what we have behind that web page is so some CSS, but that we kind of don't care about it. A very, very small page. I don't know if you're familiar with HTML, but that's basically 6 divs, one for the title, one for the different images. And more importantly, they all have IDs, and they don't display by default. But then we use Naoki, and we subscribe to some events with this function here. Can I zoom in a little? Yeah. We subscribe to some events. The events are some critical part of the memory of the robot because they are used for communicating between the different components of an application. So of course here our application is just a small dialogue without any content behind, any engine behind. But the idea is you write first an engine in Python, in C++, or anything that make the robot do things. You have the dialogue as an interface, and you have the tablet as another interface. And they are all communicating through events. So here I'm subscribing to some events. This one is interesting for us. It's called demo/show image1. And if that happens, the web page will display the part called show image1. And this is the front of the phone I was showing you before. This web page is here in Choreograph embedded in a HTML folder, so it can be accessed from the robot when we install the app. So I'll just add. show a web view. A new box. All the basic functions are there, as I was saying. So this one is for displaying the web page of the application on the screen. So if we simply play that, the robot will do this dialogue, but also display the web page. Yeah, loading, nice. Is there something here? Ah, we lost the connection. Oh, come on. Sorry for that. The Wi-Fi is a bit slow. It's a bit too small for connecting all the time on the robot, so I will just end up quickly. Oh, come on. Oh, you changed the password of your robot. Yes, you did. So why can't I connect to it? So anyway, you'll have to trust me on that one before I can reconnect to the robot. Do you want to? Yes, good. Here we go.
Good morning.
And we see the web page coming up on the screen. This web page is just displaying.
I'm happy to hear that. So tell
Pepper
me,
and welcome.
Jonas, what kind of phone would you like?
But as we have created an event that the web page is listening to, we can easily raise that event. Like if I select an Android, for example, raising an event is very easy as well. Just demo/show image 1, for example. And then let's say this is the front. And then let's show image 2. Demo/show image 2. And this is the back. Oh, sorry.
Good morning.
So let's see what it does. Hello. 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 Oh, come on. Hello. Hello.
Hello, Jonas. How are you?
I'm good. Good.
Oh, I'm happy to hear that. So tell me, Jonas, what kind of phone would you like?
An Android.
Cool. Okay, sure. I have one. This in the front, and this is the back.
And you see the web page reacting to the small events. So just by adding these small comments here, you have the web page reacting and showing the display. So if we round up everything, so we have a component in Choreograph here. That's what I was explaining. Can be programmed in Python, in C++, or in Java. Running some architecture of program. So here it's just running different questions and answer. And then you have the dialogue for speaking with the users. This dialogue is using animations, it's using sounds, and it's using some events to communicate with the rest. Plus you have the display that is displaying web pages. Web pages are programmed in JavaScript, and you can also raise or follow those events, so you can interact with all components. Oops. If I could run product information, there we go.
Hello, I am Pepper.
This
I
is
know
what it
all our
should do at
products.
the end.
Show me the code so I can give you more information.
Oh, I need a barcode. So you have the robot speaking, moving, displaying something.
Oh, I'm happy to hear that. So tell me, Jonas,
I think I
what kind of
forgot to stop
phone
the
would
other
you
one.
like?
Let me just stop that one. Right. So we have the robot here. It's speaking. It asked, "Show me a product, so I can give you information." It displays how to show a product, and it's actually trying to read barcodes. So I'm just going to find a barcode somewhere.
No one? Okay, too late. See you later.
Ah, okay. Let me start again. Product information.
Hello, I am Pepper. I know all our products. Show me the code so I can give you more information.
Robots, huh? Yes.
Hello, I am Pepper. I know all our products. Show me the code so I can give you more information.
Would you mind reading that? Okay, so I'm going to enter the code manually because it doesn't seem to be nice with me.
Now is a small and cute humanoid, designed to be a true daily companion and an innovative educational platform. It is a fully programmable robot which is now a standard in research and education for primary, secondary, and special education.
So what you see here is basically a bit finished version of what we started with the phones. The robot is talking, asking for some codes, reading the codes, or you have seen here, it's also possible to enter the code on the screen. Then once he has the codes, he looks in the database of the different products and, well, plays his speech. While it's speaking, it's still moving, it's still displaying information. So you have different approach. When you do that, you have a shop with a database of products. You can display information, but you also need something more. And this is where it becomes interesting. You need the robotic part of it. So you need to put some information for the robot to speak. That means speaking, moving, having some sounds, and not only
No one?
reading
Okay,
descriptions.
too late. See you later.
Yeah, it's finished. I think that's pretty much everything I wanted to show you. Do you have any questions? Yes?
I think it's rather complex to build a GUI like that because all the different levels of communications to code is pretty high. Is that kind of standard library which surrounds communication, something like this?
So it's complex because you have different parts to program. Oh yeah, you had
Specifically the communication part.
the communication part between.
Answers and so on.
Yes.
Is there a kind of library that you can use to have a normal communication?
So for all the basic questions and answer, we provide with the robot what we call collaborative dialogue. That is making the robot able to answer all the questions, like Andrea was showing at the beginning, what's your name, how are you, who are you, and so on. All those are already available on the robot, yes. But for any specific use, then you have to program and kind of foresee all the possible questions the user could ask. And this is where some external, either artificial intelligence or a natural language classifier can be interesting, as you can send the raw inputs of what the user said and get what it means behind. What we provide here is just a basic tool for providing questions and answers, but for specific questions. Of course, here our triggers are very, very small, just Android or just I'm good. Where was it? Yeah. So just hello, good, bad. But you've seen here it's already a wildcard, so that means I can say any sentence ending by good. You have a lot of mechanisms like that to make it easier to cover a large field of possible questions. Can the robot move around? Yes, of course. The robot's on wheels, so right now it's forbidden to move. But if we close it, and then go back to our program, up. Then there is somewhere a box called move that we can directly use. Up. So we'll just remove the dialogue. I like talking with that robot, but it's becoming a little repetitive. And here it's a very simple move. We ask the robot to move 1 meter forward. Yeah, that's not 1 meter. So there are probably some securities coming in saying, okay, I cannot move. We usually see some sensors here triggering while stopping the move. This is just kind of not intelligent at all move. Like you ask to move 1 meter forward, if there is an obstacle in front, it stops. So maybe we should go backward and then it doesn't have any obstacle. There we go. So the robot is on 3 omnidirectional wheels. That means it can, of course, drive forward, backward, but it can also do any kind of rotation or sideways moving, not walking. The idea is always to have something very smooth. Even if right now the robot doesn't embed any mapping for big environment, for example, we're still able to move in small ranges around to make something nice for the users. Like if you have different products here, some here, then the robot can actually show and go there. The hands, no, they are not built for handling things. They could hold a few 100 grams, but that's it. And anyway, they're not built for grabbing things. They cannot open enough, for example, to actually grab a pen on a table, something like that. It's really only designed for interaction and, well, pointing at objects or just have nice movements. Yes? How many languages do we support? I repeat the question. We are using the Nuance engine, and they have 28 languages in the catalog. Right now, we have embedded in the robot 10 of them, I think. So English, French, German, Spanish, Italian, Chinese, Japanese. Well, we are slowly integrating all the languages, but well, it still takes some time. But the robot right now can speak something like 10 languages. Yeah. Yes, indeed. The robot is able to detect emotions. That's something embedded, and that's something we are basing a lot on. Our thinking is if the robot is interacting with people, it has to feel what people are actually feeling. Our ex-boss was actually saying, I want to know if someone says no when he means yes. So that means understanding with your face, with your voice, with the tone of your voice, with your body language, what you are feeling. So we are basically extracting all those features. So there is a face filter that try to see if you're smiling, if you're frowning. There is a semantic analytics as well on the words you're using. And there are some filters on the tone of your voice and on how you're moving or standing in front of the robot compared to the background of the room. With all those compelled, then we kind of create a probability of mood over, I think it's 5 different basic moods to extract. So it's able to tell if you are happy or not. It's also trying to extract your age, your gender, all this from your face. And all those are available from any program. So that means you could, here you had a dialogue that is always the same, but you could imagine having different dialogues depending on if you have an angry user or a happy user in front. Like if the robot is at the entrance of a bank and a very angry customer comes, it might be tactical to just call someone at the front desk and say, okay, I want a human to help me because the robot itself now. And in the meantime, the robot would tell jokes and that's it. Yes?
Can the robot be connected to sensors, something like temperature, that it can tell, let's say, very hot today, you want this, or to cloud services, for example, if you have a private music store and someone sings a melody and it goes to one of those services, soon it recognizes the melody as everyone that is by this.
Yeah. So the question is, can the robot be connected to external sensors or services, web services? The answer is yes. It's a computer, it's connected with a Wi-Fi. From there you have access to everything. We have done a lot of examples with domotic, for example, so the robot can switch on and off the lights, read the sensors for temperature and everything like that. All the step counters you have with you, you can very simply, they all have web services, so you can very simply access those from the robot, give information, get information, and use that in the different programs. So for example, in our small example here of presenting products, we could imagine having the store displaying some of the products with some very smart lights showing one of the products. If the robot is presenting one, we could imagine switching the lights, just showing that product in the shelves. Or on the contrary, getting information from the web services to get the list of the products and what the robot has to say regarding any product. We usually say that in a store when you have 1,000 products, all the vendors cannot know every detail about all the products. It's not possible, but for a robot it's not a problem as it has access to the database of those products. So if you have 100 different computers, then the robot can just give you all the specs for all the computers. That's very easy, as long as you have web services and databases available. So yeah, the answer is yes. Yes?
How long does the robot last on battery charge and how does it get charged?
The robot lasts, how long does it last on the battery and how long does it charge and how does it charge? For charging, the easy way right now is to plug a charger here. So we just open that little hatch and plug the charger. We are on the way of releasing a charging pod. So the robot will just drive on it and charge itself. Once the battery is charged, it's about 4.5 to 5 hours to charge. It can last minimum 12 hours on the battery. So what we want is a robot that is able to work a full business day without recharge. So you recharge it overnight and it's able to work all day.
So thanks. I think we have to stop because the lunch is on now and in 5 minutes the large rolling is going to go there. So if you want lunch,
Run!
Thank you very much for the talk. It's really cute bot. If you
Oh?
There's another talk featuring now at 10 to 3 if you're
Hi,